Today I want to go through a presentation that was recently made at the ICES, that's International Congress for Exploration of the Sea, symposium on marine ecosystem acoustics that was recently held in Nantes, France. The subject of the presentation is the development of an acoustic tag that directly determines when a fish has been predated by a larger fish or marine mammal. Acoustic tags have been used extensively to study fish behavior in fresh water and marine environments. The temporal and spatial behavior of individual fish can be studied by observing the three-dimensional tracks of the tagged fish. By placing receivers along the migration path of a fish, the survival of a particular fish can be studied as it proceeds along its migration path. In many cases, predation can have an important effect on the overall survival of smaller fish, in particular salmon smolts, and by larger fish, marine mammals. And an acoustic tag has been developed that directly determines when a tagged fish is consumed by a predator. And that is the subject of today's presentation. This shows an example of a typical application of acoustic tags. This is an overall view of the Sacramento River. The river flows from the top here down in the direction shown. And this is Georgiana Slough, an irrigation canal off the main stem of the river. So in this case, there's 4 tagged fish that we've tracked. 2 of those tagged fish remain in the main stem of the river, and 2 of the fish end up going into Georgiana Slough. In order to keep the fish from going into the channel, Georgiana Slough, they've built a barrier to keep the fish in the main track of the river. This is an interesting case that shows 2 tagged fish whose tracks are coincidence as shown here. Now, clearly what has happened in this case is that the 2 tagged salmon smolts have been consumed by an individual predator, and what we're observing are the 2 tags in the stomach of the predator fish. This is a unique case where 2 tags have been consumed by an individual predator. In many cases, only 1 tag is consumed by the predator, and the track of the predator may or may not indicate that that tagged fish has been consumed. In order to deal with all those cases, both the case where it's obvious from the path of the tag and those cases where it's not, we have developed a tag that directly detects when the tagged fish has been consumed by a predator. In the upper left-hand corner of this slide, I show a traditional acoustic tag without the encapsulation. It has 3 components: the batteries, the electronics, and the acoustic transducer. On the right-hand side, I've shown an encapsulated predation tag. This construction is basically the same as this unencapsulated tag, with the addition of what we're calling a digestible fuse that is on the outside of the tag. This digestible fuse is covered with a material that is not normally affected when the tag is implanted in a salmon smolt, for example. But when the tag is consumed by a predator, this outer coating and this fuse material dissolves through a process of digestion. The exact details of this have been patented. The predation tag, as we are calling it, has the characteristic that you're still able to do all the 3-dimensional tracking and detection events just like you are with a normal tag, and also determine when the tag has been predated. This shows the signal design that we use for the normal tag and also the predation tag. In our normal tag, we transmit two pulses closely spaced, a double pulse pair as we call it, and the actual tag identification is encoded in the period between these pulse pairs. So by accurately measuring this time from the arrival of the first signal in the pair to the first signal in the next pair, we can determine the exact period, and from that determine the ID of that particular tag. In the predation tag, what we do is that we again have two closely spaced signals, and we have pairs of tags. However, in the second or sometimes in the third pair, when the fish has been predated, we increase the spacing between the first and second pulse in this pulse pair. Doing this, we still can determine the tag ID because we know the period from the first signal to the first signal in the second pair, etc. But we can also determine that the tag has been predated by this increased spacing in the pulse pair. This shows the actual signal arrival times for one of those tags. So the spacing between the first and second signals is the normal spacing that we would have in the pulse pair. And then when a predation event occurs, we see a third trace. So we have the first and second trace between the normal spacing between the pulse pairs, and then we also have this additional trace occurring on either every other pulse or every third pulse, indicating a predation event. Now, in order to go through and evaluate this technology, we did some testing with the help of the California Department of Water Resources and the U.S. Department of the Interior Bureau of Reclamation. California Department of Water Resources had a facility in which they had striped bass that were trained to feed on demand when they put juvenile salmon into the tank. So what we did was that we actually went through and tagged a number of these juvenile salmon, put them into the tank with the striped bass, and then measured the time it took for the predation tag to trigger. In addition, there was a control group of 30 tagged Chinook salmon that were held for 30 days just to ensure that we had no false alarm. With this test, we found that the mean time for triggering was 59.3 hours, and a standard deviation of 28.1 hours. And the control group had no false triggers. Further observations have shown that the actual mean trigger time is very much dependent on the digestion process in the predator. When we found that free-swimming predator typically is hungrier than one of these trained predators in the tank, and the predation tag will trigger more rapidly in a free-swimming predator. We went through and did some trials with these predation tags in the Sacramento River, and this first plot shows the path of two tagged salmon. So here they're up at the release site, and this is a plot that has days from the release and then river miles from the release site, and it shows the detections at these various sites as the free-swimming salmon smolts proceed down the river towards the Pacific Ocean. This next plot shows the path of a predated fish. So again, the fish is released up at the release site at day 0 and river mile 0. It proceeds along the river, and at the first detection site, we detect a trigger event. The fish continues to proceed down the river, and we detect it at further sites down the river. At this point, if it weren't for the predation tag, we would think this is just a completely normal path for a free-swimming smolt. However, what we find is that when it makes it down to this point in the river, it turns around and goes back up the river. This is not the behavior of a free-swimming smolt, and continues on up the river and eventually makes it all the way back up to the release site. Here's some summary results for those tests that we made. So these were for fish that were released over a 4-day period between May 6th and May 10th in 2014. And so we have a plot that shows the days from the start of the study, and we can see that we released these tags over the 4-day period. So the left-hand edge of these lines is the release times. And in many cases, we detected the tags as they traveled down the river, some of them traveling more rapidly than others, and a number of them were not predated fish. However, in some cases, we do see that the fish were predated, and we continue to see the detections of those predated fish. In some cases, they were detected as predated, and then later, the predator defecated the tags, and so the tags remained stationary. We continued to see those over a long period of time. In conclusion, predation can be a major factor in determining the overall survival of a fish as it travels along its migration path. Predation can sometimes be inferred from the three-dimensional tracks of the fish, but not always. In order to be able to definitively tell when a fish had been predated, HTI has developed a predation tag with a digestible fuse that directly indicates when the fish has been consumed. We have done some testing of this predation detection tag in controlled experiments and field trials. Thank you very much.